The project title is Cystic Fibrosis Detection Using Human Sweat. The aim of the project: to find cystic fibrosis in human sweat images, to describe to what degree the person is affected by CF. Objective: to process the sweat image using wavelet transform and to find the probability whether a person is affected by CF. Introduction: inherited monogenic disorder presenting a multisystem disease. Cystic fibrosis is caused by the gene CFTR, cystic fibrosis transmembrane conductance regulator. If CF is present, the mucus becomes thick and sticky. It blocks the airways and tubes. Cystic fibrosis affects mostly the lungs and the digestive system. CF causes the sweat to become very salty. This causes unbalance of minerals in blood and causes many health problems. Proposed system: the main need for the system is due to its existing system. It had many difficulties in diagnosing the patients with CF disease. Proposed system involves the use of taking sweat images from the human body and applying wavelet transform to check for cystic fibrosis. Workflow: sweat skin, UV thermal camera, UV thermal images, linear filter, wavelet transform, statistical analysis, cystic fibrosis data. Agar-agar medium: to capture the cystic sweat image, an alternative medium is created by using agar-agar medium. The agar-agar medium will act as a cyst and agar-agar gel will resemble the sweat skin. UV camera: the UV light is capable of penetrating through the dermis of the skin, so it is done to show how deep the cyst has developed under the skin. The UV camera used is Zensis. Thermal camera: thermal image tend to show the heat distribution surrounding the skin. The heat will later start to increase gradually and cause more pain. The thermal camera used is Fluke VT02 visual IR thermometer. The captured images, the collected images: UV image, cyst image, thermal image. UV image: normal UV sweat image will show the degree of UV light penetration through the dermis of the skin. Cystic sweat image will show will not penetrate through the dermis since the formation of cyst. The difference between the two images cannot be viewed directly through naked eye. The difference can be viewed only through MATLAB software. The UV images processed in MATLAB and the results obtained are: for normal sweat image and cystic UV sweat image. We can see the difference in graph rising to the peak. Thermal image: normal sweat image, heat will be distributed on the surface of the skin during sweat and the heat distribution is clearly described with RGB color representation. Cystic sweat image, the heat will directly increase and the pattern is shown in the image due to increase in temperature. Thermal images results: normal thermal sweat image, cystic sweat image. We can see the increase in graph. The filter used is a linear filter in which we have used the convolution theorem and to reduce noise, edge detection and blurry images. We have used the Bibo condition, bounded input and bounded output condition. The formula used: y of n is equal to summation infinity k is equal to minus infinity x of k h of n minus k. Wavelet transform: it may be considered as the time frequency representation for continuous time signals. Histogram coding will predict the difference between the normal image and cystic image. Wavelet coding will show the decomposition ratio. This is the coding of the project. This is the wavelet coding. And the decomposition ratio is not necessary to use only thermal image or UV image. Either of the two, the decomposition ratio can be formed, and the results of decomposition ratio is 83.3. Histogram comparison of UV image to show how far the cyst has developed in the skin. This is the coding for histogram program. It's quite simple. Histogram comparison of thermal image. The normal image shows the output that heat developed during normal sweat image will be different and similar to body temperature. The cystic output will show the heat developed in the cyst will increase the heat around the cyst and cause pain. Thank you.